the last session, we were doing simultaneous equations. I'm going to do, in this session, I'm going to do 2 more simultaneous equations, right? They're fairly long ones, and maybe we'll start introducing the mathematical modeling section. But essentially what we've got here is they have said to us, here's an example. This example is x squared minus 3xy plus 2y squared equals 4. And they say to us this over here. The next one is 3x minus 2y equals 0 or 0. Okay, now pretty much we don't know what the first graph looks like. Okay, we've now into uncharted territories that we've got to go through. We are asked to solve them simultaneously. Right, what do we do? Obviously, look at equation number 1. Let's just look at it. X squared minus 3 times xy plus 2y squared. You actually can't separate those out to be able to make any one of them the subject of the formula, right? It's going to be a complete mess. Okay. In fact, you're really going to, you can't bring them to separate them. You can't get x or y as the subject of the formula. Okay, it's going to be a complete and utter, and time wasting as well. The secret is always, step 1 is always choose the easiest option. Okay, this one is easier. I can make y or x the subject of the formula. Okay, remember in the previous one with the circle where we had x squared plus y squared equal to something, I don't know, say 100, right, like that. You're not going to go and look at substituting y, because that's going to be 100 minus x squared and square root of it. That is very difficult, okay, to put into something else. Here, all right, we say, okay, now we said, right, try to keep away from fractions, remember? Try and keep away from fractions. Unfortunately, in this case, look at it. You can't. This is our equation number 1. This is our equation number 2. When I now go, remember, these are all substitutions, right? When I now go and I say, right, make x or y the subject of the formula, I'm going to say, all right, 3x is equal to, okay, minus 2y. Therefore, x is going to be minus 2y over 3. And let's try the other way. 3x minus 2y equals 0. Let's take the x. Minus 2y is going to be equal to 3x minus y is therefore going to be minus 3x over minus 2, which is 3 over 2x. Right, so in fact, in both cases, okay, we have fractions. Okay, unfortunately, we have to use them. We don't have any option here, all right? So let's put them in. So now do the substitution. Okay, let's substitute in. X squared minus 3x times 3x over 2 plus 2 times 3x over 2 squared is equal to 4. Wow. Now let's remove the brackets, shall we? This is going to be x squared minus 3 times 3 is 9x squared over 2. Plus, okay, that comes to be, well, 3x over 2 all squared. Remember I said previously, 3x over 2 change them to that if you want to. That means we've got 3 times 3 is 9, x squared over 4. Times 2 now gives us 18x squared over 4 is equal to 4. Now what's the next step? The next step is we've got to multiply through by LCD. We have fractions, right? Remember, fractions, therefore, times by L, oops, that's not a nice LCD, times by LCD, i.e. in this case is 4. Now remember, when you do it, right, what do? You go back to it and you say 4 times. Okay, well, sorry, there, 4 times 4 times 4 times 4. Why do I do that? So that we don't forget to multiply each and every term by 4. Remember, we cannot leave any terms not multiplied by the LCD. That gives us an eventual thing of 4x squared minus 18x squared, all right, plus 18x squared equals 16. Now you can see that what looked like a very complicated thing has dropped to 4x squared equal to 16. Therefore, x squared is going to be equal to 4. Therefore, x is plus or minus 2. Right? What do we do now? Now we back substitute. We back substitute, x equals 2, and therefore y is going to be equal to 3 times 2 over 2, which is going to be equal to 3. And x equals minus 2, y is going to be 3 times minus 2 over 2, which is going to be minus 3. So the points of intersection of these graphs is going to be plus 2 and plus 3 and minus 2 minus 3. Okay? Plus 2 plus 3 minus 2 minus 3. Let's do another example. Okay? X minus 3 equals 10. Okay? And y, x minus 3y equals 10. Sorry, my apologies. Y is equal to 3 divided by x minus 4 and minus 2. This is equation number 2. This is equation number 1. Now we're saying, all right, how do we do this one? Okay, well, let's see. Generally, it's substitutions. If we multiply an equation 2, if we multiply through by x minus 4, we're going to get x's times y's. And we're going to end up having to substitute from 1 anyway. So always start with the simplest one, which is the straight line. In this one, if I decided to make y the subject, I'm going to have 10 minus x all over 3. No, don't like that. It's got a fraction. Don't want fractions. X is equal to 10 plus 3y. Right? Therefore, what can we do? Let's get the other page up. Okay, like that. And go back to that. Now, what have we got here? Okay, well, we say, let's have a look now. Y is equal to 3 over x minus 4, okay, minus 2. Okay, by the same token, okay, I don't want this fraction here, do I? I do not want this denominator. What do we do? Times by LCD. Okay, by now you should have gotten the pattern, okay, the recipe for this. So we say, okay, y times x minus 4 is equal to 3 minus 2 times x minus 4. Okay? Now, what do I do now? All I've done is I've gotten rid of the LCD. My next step is to do what? My next step is to substitute for your chosen variable. Okay? And in this case, we chose our x, didn't we? So we said that is y is equal to, now I'm going to substitute, here we go, let me just put in, I'm just going to put in here, we're going to substitute for the x's, aren't we? Right? Y is going to be equal to 10 plus 3y minus 4 is equal to 3 minus 2 times 10 plus 3y minus 4. Okay? Like so. What is my next step? Well, my next step is to say, okay, multiply out y, and this is going to be 6 plus 3y is equal to 3 minus 2 times, and the next one is 6 plus 3y. Now we multiply out 6y plus 18y squared is equal to plus y, did I do that? Okay, sorry, 6y plus 3y squared is equal to 3 minus 12 minus 6y. Okay, what's my next step? Well, next step, rearrange and see what we get. We end up with 6y plus 3y squared, okay, plus 6y, okay, plus 9 equals 0. Finally, 3y squared plus 12y plus 9 equals 0. Divide by 3 or put in your calculator if you're allowed to use them. Okay, divide by 3 to simplify, plus 4y plus 3 is equal to 0. Now, factorizing this the old way, let's have a look. Because this one we can. Y equals and y equals y plus 3, y plus 1. Therefore, y equals minus 3 and or y equals minus 1. What do we do next? Well, next we back substitute. Okay? Back subs to find x. Okay, so I like to do it like this. Y equals minus 3 and y equals minus 1. Like the little table I did before. Okay, that's a personal preference. And if I put it in, I get x equal to 0, or 10 plus 3y. So x is going to be equal to 10 plus 3 times minus 3, which is 1. And in here, x is equal to 10 plus 3y. So x is going to be equal to 10 plus 3 times minus 1, which if my mind is correct, it's a 7. Finally, I've got my coordinates of the point of intersection, and they are 1 and minus 3 and minus 1 and 7. Those are the points of intersection of those graphs. Whoops. Yeah, 7 and minus 1. Look what I did. Okay. Sorry, 7 and minus 1. 1 minus 3 and 7 and minus 1. All right. I'm so used to writing x and y the other way around. Solving for y after I've got x. So let's see. Then there's another one. Okay. They say find the coordinates of the points of intersection of the following graphs. Right. The following graphs. And they give us this. X squared plus y squared is equal to 100. Okay, and 4y plus 3x, 4y plus 3x equals 50. what am I going to do? Well, first of all, I've got no option. We're not going to mess around with the squared. So I did this and I said, right, y is going to be equal to 50 minus 3x divided by 4. And then I said that is going to be 25 over 2 minus 3 over 4x. Okay. This one is pretty heavy. Okay. But watch it. It looks in the beginning, and a lot of students are like, oh no, watch how quickly it breaks down into something very simple because stuff cancels out. All right. Now I say, right, therefore that is going to be x squared plus, and I'm substituting for this. 25 over 2 minus 3 over 4x all squared equal to 100. Right? This is what we've substituted in for y. And don't forget we had to square it. Just change my pen back. That gives us this. How do we square out that bracket? Well, we take it to the side, minus 3 over 4x, and you break it apart like that, minus 3 over 4x. Then you put in your bridges, right? Like so and like so. And now we're going to multiply them out. Eventually, that looks like a mission. You get 625 over 4 minus 3/4 times 25 over 2x, okay, plus 9 over 16 x squared. And what are we going to do? Times 2 of those. Okay. Cutting a long story short, we put it back in and we get this. X squared plus 625 over 4 minus 75 over 4x plus 9 over 16x squared equals 100. Right? Rearrange, multiply through by LCD. Okay, how do I do that? What's my LCD? Times by LCD, which is 16. So I go 16 times 16 times 16 times 16 times 16. All right? We multiply each and every one by 16. Right? Now, when we've done that, this is what we get. We get 25 x squared minus 300x plus 2,500 minus 1,000 equals 0. Simplified, 25x squared minus 300x plus 900 is equal to 0. Divide by 25. Minus 12x plus 36 equals 0. That factorizes into x minus 6, all squared equal to 0. Right. How cute is that? It all factorizes down to that. And that gives us x equals to 6. Therefore, y is going to be equal to 50 minus 3 times 6 divided by 4, which is going to be 50 minus 18 divided by 4, which is equal to 8. Therefore, the points of intersection are 6, 8. There you go. Now, so okay, that's fine. But now, all in all, okay, let's just summarize this, right? Just for a interest, what have we got? We say, let's say we've got AX. This is types. Just so you know what you're looking for. AX plus BY equal to C. This is straight line. And they say this is DX plus EY equals F. Another straight line. Okay, straight line crossing a straight line, you're going to get 1 point of intersection. Okay, you're going to get 1 point of intersection. So a straight line and a straight line gives us 1, obviously. There they are. It's just going to do this, isn't it? Okay, then let's say we've got AX plus BY equals C, and let's say they give us X, Y equals K. K is any number, guys. That's basically Y is equal to K over X. Those of you who do physics, that's quite a well-known one, isn't it? Okay, inverse proportion. This is a hyperbola and a straight line. So basically, if you've got a straight line and a hyperbola, we say, and I'm going to say you expect 2 points. Because it's going to be something like that, like so, or obviously, and I mean, the hyperbola could be there, and we're going to get a line like that, right? So you're going to get, in all likelihoods, 2 points of intersection, are we not? If we now, get my pen back to it, if the next one, if we've got something that looks like this, x squared plus y squared with coefficients a, b is equal to d, okay, x squared by d, and we've got y is equal to mx plus c. This is a circle, this is a straight line, right? Therefore, expect 2 points of intersection. Okay? Expect 2 points of intersection. Now, the last one, well, not really the last one, but there's this and one more. Let's say they give us ax squared plus bx equals d and y equals k over x. We expect, look at this. This is a circle and hyperbola. How many do you expect? You expect 4. Why? Well, if you just draw the circle like so, and you put in the, like that, right? There they are there. Okay? Obviously, the hyperbola, just to finish it off, could be over there, couldn't it? Right. And you get 4 there like that. Okay? Parabolas, same story. Okay? If you've got straight and a parabola, you've got basically what? There and expect 2. Okay? I very much doubt you're going to get parabolas, circles, okay? Or you're going to get hyperbola, circle. But just on those basic ones, expect 2. Well, what happens if you only get 1? Only get 1 point. Okay? Well, what it means is, let's take this. Let's say we've got a circle over there, right? And when we actually, we only find 1 point. What does it mean? It means that it's only touching at 1 point like that. This then is the tangent. Right? You could also have it with a hyperbola, couldn't you? Look at this one. Okay, let's just have this and that there. And we get 1 point of intersection. Let us say it's there, possibly, like that. This line is the tangent to it at that point, is it not? So, That brings us to the end of the section on essentially where we're doing simultaneous equations, finding points of intersection of graphs, which is essentially simultaneous equations. What do? Well, we look at them, and if we can discern what they are, just whatever we know, say one's a parabola and one's a straight line, we sort of expect 2 points, right? And we always take the simplest equation. It's always going to be a substitution method, unless it's 2 straight lines, obviously. But it's a substitution. Take the simplest one, usually the straight line, and convert that into a y equals or an x equals. But remember, try not to have a fraction in there. That's important. Okay, important only because it makes it less complicated. Right? That's the only reason at all. The next section is to say, right, then substitute in, and remember, the maths of this is really, it's not maths, it's arithmetic. So just be careful. And if you are allowed to use, just check yourself and work it out slowly and concisely. Okay? Don't rush in there and go bang, 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 and try and do 20 calculations at once, because the chances are the brackets are not going to be right or whatever. Just because it's complicated arithmetic that we've just done, take it easy, take it slowly. The next step is to then, when you've done the substitution and worked it out, solve. You're either going to get 2 x's, which is going to give you 2 y's. You're going to get 4 x's or 4 y's, which is going to then give you 4 x's, right? To give you all the points of intersection. It is really not complicated maths. It's complicated arithmetic. It's very messy stuff, this, okay? You're going to see in the next section where we talk about mathematical modeling, the mathematical modeling side, okay? That is equally laborious, all right? We got equations over here of x squareds with thousands and so on. You'll see in mathematical modeling that you get that kind of thing, right? Now, just basically, if you look, please remember when you are seeing problems, some of the problems they give you is they will say to you that, for example, an arch bridge is a parabola, and they give you the height of 100 meters over there. Let us just say, all right? And they want to know where the road across intersects it, all right? You're basically going to move your points there, and you'll work out the equation of that. Work out that, and you find the point of intersection, okay? We'll do some of those probably in the exam prep, etc., etc. Thanks for watching. The next session is I'm going to do, it's basically combined grade 10 and 11, okay? It's the mathematical modeling section where we're going to talk about problems of age and numbers, financial, etc. I am going to take my time through it. I've got quite a lot of it's probably going to be 3 or 4. As I said, I'm combining grade 10 and 11. The reason being is that this section is, you're always going to get a word sum, right? It's going to come. The word sums are usually worth quite a bit of marks, and you know what? As long as you can recognize which type it is and then go straight to the table, I'm going to use a table method to solve them. You put in the numbers, find out what's missing, okay, and solve. They're not difficult at all. I know I say that a lot, but they really aren't. We're just going to follow the recipes for it. I'll see you in mathematical modeling, which in essence is really, it's taking what we know and we're turning it into actually solving real life problems. Cheers. Have a great time. Bye.